In this video, we are going to solve a problem using the Mohr circle. So for this problem, we are given here an element with a given stresses. So in the x-axis, we can see that sigma x is 32 megapascals tension, and tau xy is negative 20 megapascals, and that is in a counterclockwise direction. While on the y-axis, the stresses are sigma y equal to negative 10 megapascals compression, and tau yx is 20 megapascals in a clockwise direction. We need to find, for letter A, the view of the element having the principal stresses, and for letter B, the view of the element having the maximum shear stress. So the first part of the problem is to construct the Mohr circle. So in this sigma and tau plane, we are going to plot the stresses of the element. Sigma x is 32 and tau xy is negative 20. So from 32 megapascals here, we move down because it is counterclockwise. So the coordinate of point A is 32 comma negative 20, while on the y-axis the stresses are negative 10 and with a clockwise shearing of 20. So this point B is located, we move negative 10, then upward 20. So the coordinate of point B here is negative 10 and 20. So we need to compute for the radius of this circle R. So we can use Pythagorean theorem to this side here can be computed, and this one is given to be tau xy. So this distance is sigma x minus sigma y over 2. To compute for R, we are going to use the Pythagorean theorem. The square root of quantity sigma x minus sigma y over 2 squared plus tau xy squared. Substituting values for those variables, so it means that R is 29 megapascals. So this distance is 29 megapascals, okay? And that happens also to be the distance here for the tau max. So to compute for OC here, OC is sigma x plus sigma y over 2, and substituting values, we have OC equal to 11 megapascals. So if we are going to compute the rightmost point, the coordinate of this, we need to compute the total distance from O to point 1, which is equal to OC plus this distance, which is also R. So OC plus R. So we can compute for sigma 1. And for sigma 2, it will be OC minus R. Okay, so that will be OC minus R, so that is negative 18 megapascals. So we also need to compute for this angle from the x-axis. If we arrive at this sigma axis, it means that we need to rotate for a certain angle of degrees. Now, we can use tangent here. Tangent of 2 theta is tau xy over this distance, no? So that is tau xy over sigma x minus sigma 2 over 2, sigma y over 2. So tau xy is 20 divided by this quantity. So 2 theta can be computed. It is equal to 43.6 degrees. So half of that is 21.8. So to draw the view of the element having the principal stresses, so we need to have the angle 21.8 degrees, because from the x-axis we move for 2 theta in the Mohr circle, in which the angles here are doubled. Here in the x and y plane, the angle here is just half of the angles in the Mohr circle. So we have here 21.8 degrees. Draw a line there and draw an element having sides parallel and perpendicular to that line, and sigma 1 is already solved, 40 megapascals, and 90 degrees to that is sigma 2, which is negative 18 megapascals. So to have the letter B, which is the maximum shear stress, we need to find this angle. And from this figure, we can see that 2 beta here is equal to 2 theta plus 90 degrees. So we can also compute for the angle there, 2 beta is equal to 2 theta plus 90 degrees. So 2 theta is 43.6 plus 90. So the answer is 133.6 divided by 2. It is 66.8 degrees. So for this plane where the angle is 66.8 degrees, we can find the element when it is already in the maximum shearing stress. Okay, so what we can see here for tau max, the coordinates are OC, and the tau here is tau max, which is equal to R. So the value of the stresses here along that line, which is 66.8 degrees, is 11 megapascals with a shearing stress of 29 megapascals. And on the opposite side of the circle, the most bottom circle, part of the circle, that is tau maximum, also in a negative value. So the coordinates there are OC and negative tau max. So we can plot the stresses here. OC is 11 megapascals, and tau max, which is in the negative direction, counterclockwise, is negative 29 megapascals. So note that tau max is also equal to R. So that's all, folks. Thank you for listening.